Okay, let's find the domain of a rational expression. And again, the domain is what x can be in an expression. So let's say we have y equals 1 over x squared minus 9. Okay, it might be easier to start thinking about what x cannot be. Anything we put into x here cannot make the denominator 0. Because if the denominator is 0, then the expression y equals 1 over x squared minus 9 is undefined. So let's start with that as a starting point. X squared minus 9, which is the denominator, cannot be 0. Okay, now let's find out what values of x will make the denominator 0, and we can take those out of the domain. So we want to isolate x here, so we're going to add 9 to both sides. 9 minus 9 is 0, so these cancel out. And now we have x squared cannot equal 9. But we don't want to know what x squared cannot be. We want to know what x cannot be. So we're going to take the square root of both sides. The square root of x squared is x. So x cannot be. The square root of 9 has two answers. It could be plus or minus 3, because 3 times 3 is 9, but minus 3 times minus 3 is 9. So that means that x cannot be 3 or x cannot be minus 3. Okay, if we write that in interval notation to now show what x can be for this expression, we'll write it like this. Anything from negative infinity all the way up to minus 3, but not including minus 3. So we're going to put a round bracket here. And we're going to join that with the set anything from minus 3 to 3, but not minus 3, round bracket, and not 3, because that'll make the denominator 0, round bracket, union anything from 3, but not 3, round bracket, to positive infinity. So this is the domain of this rational expression. X can be minus infinity to minus 3, but not minus 3, union anything between minus 3 and 3, but not minus 3 and 3, union anything from 3 to infinity, not including 3. And that is the domain of this rational expression.